Hey guys, welcome back to AlgoYogi. Now we are doing array and hashing series. Our next problem in the list is next greater element 1. Let's go to LeetCode. The next greater element of some element x in an array is the first greater element that is to the right of x in the same array. Now you are given two distinct zero index integer array nums1, nums2, where nums1 is the subset of nums2. For each index I, which is in the range 0 to the length of nums1, find the index j such that nums1 at ith position, nums2 at the jth position, both elements are same, and determine the next greater element of nums2 value in nums2 itself. So if there is no greater element, then the answer is going to be -1. Return an array answer of length nums1 dot length, of course, such that the answer at the ith position is the greater element as described above. Well, the first time you read this problem, I'm sure you were like, what the fuck is this? Like, why they have tried to make it like so complicated? But like, let me tell you, it's a very simple ask. The ask is we need to return our answer. Basically, we can call it result, and that will be of same length as nums1. Right, so it's going to be of length 3, right? Now for each of the value in nums1 values, we have to find these values in nums2, and then from there we will try to find the next greater element for that value inside nums2. That is the simple ask. So let's find it out. Let's do a dry run here. So let's go over all the elements of nums1. So first element is 4. Where is 4 located in our nums2? Well, it's located at the position, basically second index. So 0th index, first index, second index, and third index. So now after second index, is there any element that's greater than 4? Well, there is none, so that's why we're going to have -1. Then let's go to our next element, which is 1. Well, find the position of 1 in your nums2. It's right here. It's at the 0th index. What's the next greater element towards right to 1? Well, it's right here, which is 3. So we'll write 3 here. What is the next element? 2. Find 2. Well, 2 is at the last, so there is no element next to 2. So that is why we are going to basically write -1. Sorry. Yep, so that will be our answer. That is our answer. That's what we will be returning. That's it. That's all we had to do. It's just the description has written it, making it like really super complicated, but it's not. It's a very simple problem. It's just, instead of finding the next greater element inside the same array, they have just given it find it in a next array, nums2. Find it there and then store that element. So brute force solution for this problem is going to be exact same what we have just done. The dry run here that we have done here, we can just directly translate that to a brute force solution, which will be I can just talk about it. So brute force solution will be simply, we can write just like in few steps. So for brute force solution, use a for loop. So for num in nums1, for nums1, now find nums1 or just num in nums2, and then another for loop to find next greater element, add to result array. All right, so that is it. So we have two for loops. All right, so we're going to have first for loop running on nums1, then second for loop. After you find this will give you an index, so let's say j, and you will run this loop from j to the end of the nums2. All right, and that will give you a solution of time complexity of big of n cross m, or simply n square if both arrays are of same length, right? So that was the brute force solution. Absolutely, we don't want that. We want a better solution. So what is a better solution? Well, that will be of time complexity of big of n. So now let's move to a more optimized approach. Here we will introduce a little bit of space complexity, but like that will bring down our time complexity from n squared to n. So what I'll do is, since it's all about finding the next greater element for all these elements inside nums2, that means all these elements are present in nums2. So rather than iterating over nums1 and then nums2, let me just iterate over nums2, because I will see all these elements inside my nums2 as well, all the elements that are present in nums1. So that is why I will have a dictionary. I'll call it nums1 idx index. Basically, I'm just creating this dictionary so that I'm storing all the indexes for each element. So 4 is at 0 index, 1 is at 1 index, and 2 is at second index. So that is it. Now what I'll do is, I will again try to find my result. Initially I will initialize all the values with -1, -1. Then I will have a stack, and that stack will basically store all the values that I'm seeing in nums1. Although I'm processing all the values in nums2, but if I see those values in nums1, then I will put it on top of my stack. And next time I find a value that is greater than that value inside my nums2, because it's all about, we are trying to find the next greater element in nums2, right? And if I see that value, then I will pop that value from the stack, and I will process the value for that, because I just found a greater value, and I will append that on the index after looking that index inside my the dictionary, and put that value in there. So let me just write the pseudocode and you will see. So let me draw this stack right here as well once we write the code. So what I'll do is, for num in nums2, okay, nums2, and here what I'll do is, if this num in nums1, or better would be this dictionary nums1.idx, not dot, it's underscore, and if this is in there, then I will just push it to my stack. So stack dot append this value, I'm just writing to append, and then in the end I will just return my result, remember. Okay, now most important thing right here, this will do all the trick. We'll write it here. Okay, what is that? Well, this num right here that I'm seeing in nums2, it can either be present in nums1, right? It can either be present in nums1, but it can also be a potential num that is the next greater element of any element that I've seen so far, and I saw it in nums1, and I pushed it on my stack here. So let's say what I'll do is, I'll write the code. Let me write the code here. So if num, or maybe let's say if stack is not empty, and stack dot top is actually smaller than num. If this is the case, then what I want to do is I want to pop that value from the stack. So stack dot pop. The reason I'm popping is because I'm going to process the next greater element for this value. I'll be done with it. So I don't want it in my stack anymore. So what I'll do is I will find the index of this value from my dictionary, so that will be basically nums1 idx. Put that value here, that will give you from its dictionary the value for this key, and then add that num here, because that num was greater than the top of the stack, that value. Now this was the most important line right here, or if statement line, whatever you want to call it. So let's do a dry run. Okay, what we'll do is, what's happening is I come to 1, now processing 1. Well, 1 is present in nums1, but my stack is empty, so I will put that to my stack. This line will pass, this if statement. Then what I'll do is I'll come to 3. Well, 3 is not present here, but my stack is not empty. Right? My stack is not empty. So what I'll do is, and also this 3 is greater than the top of my stack, so that is why I will process this value. So let me find the index of 1, because I found a value greater than 1. So I will find the index right here and put that value inside my result. Okay, so what is happening is I popped this value 1, and I found its index here, which was 1. Then I went to my result at 1, and then I put that num right here. So I will put, instead of this -1, I will put that num, which is 3. All right, now because I didn't see this 3 this time inside my nums1, so I'll move to the next value. 4, yes, it is present, but this right here will not execute because my stack is empty. So I will put that to my stack, second if statement, this one. So 4 right here. Then I will come to 2. Well, 2 is present here, but before that this statement will execute right here, right? But here what happens is stack is not empty, but this num4 is actually this 2, sorry, now I'm processing 2. This 2 is not greater than 4, so that is why nothing will happen here, and will append this 2 to my stack. But we have calculated our answer, because that's how our answer should have been, because there are no greater elements for 4, because 4 is right here and 2 is not greater than 2. Then for 1, yes, it was right here, but for 2 there is nothing here, so that is why this will be my final answer, and I will return that. So well, this brings down the time complexity to big of n, if n is the length of nums2, and if m is the length of nums1, then space complexity is going to be big of m, and that is because this stack and this dictionary at most is going to be of size m. All right, so that was it. Let's write down the code. It's going to be super simple. So first thing first, let's create the nums1 idx dictionary. So we'll just simply say, for each number, let's store the index. For I and num in range, let's just say enumerate. For I and in enumerate, yeah, I guess that's how you do it, nums1. That's it. Then let's have our stack, empty stack, and also let's declare our result. Result would be -1 initially, all initialized with -1 value, and length of nums1. Well, that was the answer of the problem. Finally, let's move on to visiting all the values in nums2. Now if stack and the top of the stack is actually smaller than my num, then I want to basically pop that value from my stack. So stack.pop, right, and to my result I will append from this nums idx, getting the index, right, of this value from nums1 dictionary, right, and then at that place in my result I am storing this num. Otherwise, if this num in nums1, or again, this dictionary is easier way, constant time. And if that's the case, then append it to your stack, because you will have to process that. You'll have to perform this step if you came across a number that is in nums2 and greater than this particular top of the stack, because that's the number you last saw, which was also present in nums1. So stack.append this awesome, and then you can just return the result. That's it. That will be the entire solution. Let me zoom out. So let's run this on example cases. Awesome. Let's submit it. Okay, a little bit of yep. So this is a mistake. You don't want to do it just once. You want to keep doing it for all the elements, because this one number that you're seeing could be the greater element for all the elements that you have seen in nums1 or and added it to your stack. So this right here, we will change this right here to while loop. Actually, instead of this if statement, we will change it to while. So while, all right, but that doesn't change the time complexity or space complexity. The reason that we are adding it, I want you guys to know that because your stack can have multiple values. You want to, and this number that you're seeing, because you're going from left to right, this number could be greater for a lot of values that you've seen and which are present in nums1. So you're gonna keep popping and keep processing the same number until there is a value that's whose greater element is not that value. All right. So I think now if we submit it, it should get accepted. Yes. Okay. So time complexity big of n, and space complexity is also big of n, or m, whatever you guys want to call it. I'll just call it n, considering both the arrays are same size, which is n. Let's go back to AlgoYogi, mark this problem solved. See you guys later in the next problem. Bye bye.